Hello and welcome to the lesson 20-2 practice on page 288 in your text. Lesson 21-1 was really focusing on the Pythagorean theorem, which most of us refer to as a squared plus b squared equals c squared. That is the formula version. Of course, there is an actual definition of the Pythagorean theorem. And in lesson 20-2, we uncover the converse of the Pythagorean theorem that actually tells us that we can use this to determine if it's a right triangle or if it's an acute triangle or an obtuse triangle. So recall, if a squared plus b squared does in fact equal c squared, it's a right triangle. If a squared plus b squared is greater than c squared, it's an acute triangle. And if a squared plus b squared is less than c squared, it's an obtuse triangle. So right off the bat, item 9, they want us to tell whether each triangle is a right triangle. And the way we're going to justify our reasoning is if these measurements satisfy the Pythagorean theorem as it's written. So on A, because we don't know if it's a right triangle, notice there's no actual right angle drawn because we're trying to figure out if it is a right triangle. So the main thing here, when plugging into the Pythagorean theorem, we assume if it's a right triangle, C represents our hypotenuse, which theoretically would be the longest side in the right triangle. So between 16, 63, and 65, we'll use 65 for C, the hypotenuse, and 63 and 16 really could be A or B. Really doesn't matter. But the way I have it here is we'll take 63 squared, add it to 16 squared, and we'll see, notice I'm going to put a question mark, we'll see if it equals 65 squared. If you recall in lesson 20-1, the practice, we actually used this same method to figure out if these three measurements represented a Pythagorean triple. So notice the connection here. So take a moment, see if 63 squared plus 16 squared does in fact equal 65 squared. Okay, hopefully didn't take too long on this, simply squaring these values here to see if this sum does in fact equal 65 squared. And yes, it actually does. 3,969 plus 256 is 4,225. So yes, 16, 63, and 65 create a right triangle because it satisfies the Pythagorean theorem. Now let's look at B, doing the same thing. 25 being the longest measurement here in our diagram has to be C. Again, we don't know if it's exactly a hypotenuse because we don't know if this is a right triangle. And 24 could be A and 10 could be B, or vice versa. But 25 has to be C because it's our longest measurement. So we'll take 24 squared, add it to 10 squared, and see if it's equal to 25 squared. So take a moment and see if this sum does in fact equal 25 squared. So a great example here, A, we see that those three measurements did satisfy the Pythagorean theorem, and the work we see here is that these three measurements don't satisfy the Pythagorean theorem. So this is not a right triangle, and this one is. Notice how we're using the Pythagorean theorem to determine if a triangle is a right triangle. Now on item 10, if it's not a right triangle, maybe we can determine if it's acute or obtuse based on this information here we learned in the lesson. So now our task using the Pythagorean theorem is to determine, do these three measurements represent the side of a right triangle or the sides of a right triangle, acute triangle, or obtuse? So for A, and let's just be clear here, 85 has to be C simply because it's the largest measurement. So for A, we'll say 36 is A, 77 is B. I'm going to put a question mark over it, and we'll say 85 is C. So see if that sum does in fact equal 85 squared. So 36 squared plus 77 squared does in fact equal 85 squared. So these three measurements represent a right triangle. And something I apologize, I even missed, it said if a triangle can be formed. So recall from the lesson that in order for a triangle to be formed, or three measurements to represent a triangle, the two smaller sides have to add to be greater than the third. So in item A, before we could actually know that it's a right triangle, we need to know can a triangle be formed using these three measurements? So that math is simply the two shorter sides added together. Notice I'm not squaring anything. I'm just seeing if the sum of these two shorter sides is actually greater than 85. And that is a true statement. So it could be a triangle. And now that we know it's a right triangle, now that we know it's a triangle, we prove that it's a right triangle. So keep that in mind here. I apologize for my mess up on that. So let's go and take a look at B together. Let's ask ourselves, and now we're going to take the two smaller sides. Notice they kind of reverse the order to make sure you're paying attention. Let's ask ourselves, does 18 plus 3, is that greater than 22? Well, 18 plus 3 is 21. So 21 is not greater than 22. Therefore, B is not a triangle at all. So these three measurements, if you took a board that's 18 feet and a board that's 3 feet and a board that's 22, they wouldn't connect to create a triangle. So let's press on. Now that we've kind of recalled how to first show it's a triangle, much less determine if it's right, acute, or obtuse, let's look at item C. Now, 68 is our longest measurement here. So first things first, does 33 plus 56, is that sum greater than 68? Well, 33 plus 56 is 89. So yeah, it checks out. It's not a right triangle. I'm not saying that. I'm saying that these three measurements can actually create a triangle. So now let's use the Pythagorean theorem to determine what kind of triangle it is. So I'll put a little question mark over the equal sign. Take a moment and find out what type of triangle we're dealing with. Okay, so after we plugged in 33 for A, 56 for B, again, we only did that because these are our two smallest measurements, because our largest measurement has to be C, so 68 took the place of C. We found that 1089 plus 3,136 does not equal 4,624. In fact, C squared, which is 4,624, is greater than A squared plus B squared. Therefore, it is an obtuse triangle. Last and certainly not least, item 10D. Don't want to skip past that one. Let's first find out if these three measurements can create a triangle. Do the two smaller sides, apologize for that English there, do the two smaller sides add to be greater than the third? And yes, 6 plus 11 is 17. Sure. So these three measurements can create a triangle. Now let's figure out what type of triangle we're dealing with. So we'll plug in 6 for A, 11 for B, and we'll see if it's equal to C squared. So take a moment, see what triangle we have here with these three measurements. So 6 squared plus 11 squared did not equal 12 squared. In fact, 36 plus 121 was 157. So A squared plus B squared was in fact greater than C squared. Therefore, we are dealing with an acute triangle. So this is, really just reiterating the Pythagorean theorem over and over again, but definitely something that we're going to have to memorize, that when A squared plus B squared does in fact equal C squared, we're dealing with the right triangle. If A squared plus B squared is greater than C squared, we're dealing with an acute triangle. And if A squared plus B squared is less than C squared, we're dealing with an obtuse triangle, something that we're going to have to take the time to memorize. Now, on 11, a little application with it. Shantae is making a picture frame, and most picture frames have right angles. So it says, explain how Shantae can use a ruler and the converse of the Pythagorean theorem to determine whether the sides meet at right angles. So take a moment, see if you can explain this one out based on the converse of the Pythagorean theorem. So this actually kind of hits close to home with me because I actually do take some time to build my own picture frames. And so an interesting idea here. So we can use a ruler to find some certain measurements. It really didn't matter if you focused on the right triangle ABC or the right triangle ADC. But if we found the length, and we probably should go and make sure that angle B is also a right angle, but we're focusing on angle D here. So if we found the measurements from A to D, which I called X, D to C, which I called Y, and from A to C, Z, once I find those measurements using a ruler, then I can plug those measurements into the Pythagorean theorem and see if those measurements satisfy the Pythagorean theorem. does x squared plus y squared equal z squared? And if it does, it's a right triangle, and I made a nice frame. If it doesn't satisfy the Pythagorean theorem, then I did not make a right triangle, and it's a rather wonky frame. So hopefully we're seeing how the Pythagorean theorem can be used. Hopefully we're really getting comfortable with the Pythagorean theorem, and then seeing how we can use it to determine if it's not a right triangle, what type of triangle it is. Thank you for watching. Hope it helped.